So this year I'm going to be putting my skills to the test, and I'm going to try and see if I can turn my skills into a business, or at best hone them to the point where I can make significant savings because I'm making things for myself. Right now I'm not ready for that because the workshops around me, downstairs, up here, they're an absolute mess and I need to sort that out. Equally, my tools aren't set up in a way that's the most efficient use of space, or I either have machines that are in various different states of repair, or I don't have the machines at all. So yeah, some of the machines I'd like to have, I can't afford. So I guess we might look at building them from scratch, because that's always a good idea, right? So I'm going to be starting small and hopefully bootstrap one project to the next, gaining momentum to the point where I have all of my workshops set up the way that I want them. So this is how it's going to break down. So the first phase of this venture is going to be setup. I'm going to be setting up all of my workflows one by one, documenting the process, and then we'll get into sort of some research phase as to what type of things are we going to make. This business isn't going to be a 3D printing business. It's not going to be a CNC business. It's not going to be a laser business. It's going to be a business that pulls all of these workflows together and is going to produce various different products. Now, you could be ranging from a physical item like a piece of functional woodworking. It might be that we're building some electronics prototypes, and we could get into some more exotic things. I do have plans to build a foundry and do some aluminium casting. So there's a large scope of things that we can actually work on, but I want to work up to those things incrementally as opposed to try and take everything on all at once. And each of the tool chains that we've got available to us here effectively can contribute in some way, shape or form to help us achieve a specific goal, whatever the product might be. So to that end, I've decided I'm going to work on my 3D printers. I've got two CR10 V2s, which are by today's standards a little bit old, but they're perfectly serviceable. They're perfectly fine to do the work that I need them to do. I don't need multi-material. I don't do different color prints. I think multi-material would probably come in handy if I was doing some different materials for supports. So right now, that's not something I'm looking to invest in. But that's not to say that wouldn't come in the future. So I got myself some Glass Fiber PETG, and that was at the recommendation of one of my viewers. Now, if you're not familiar, 3D printers typically come with a brass nozzle, and to print composite materials like carbon fiber, glass fiber, they are abrasive materials. So you need a hardened nozzle to resist the wear that those filaments bring to the machine. So I replaced the brass nozzle that I have on my printers with a hardened steel one, and I got all sorts of issues, under extrusions, and the print quality was awful. Now, I decided to look into this a little bit further, and I think I know what might be happening, but this is a theory. What I think is happening is that the heater block on the V6 style Hotend that comes with the CR10 is not able to maintain temperature as you're printing. What I think is happening is that the nozzle is coming up to temperature to print, and as the filament is passing through the nozzle, it's stripping the heat away from the nozzle, but the heater block is not capable of maintaining that heat. It's absolutely fine for brass, but not hardened steel. The next thing I noticed was that the Hotend has a 10 millimeter cubed per second flow rate. This ultimately influences how fast the machine can print. The higher the flow rate, the faster the machine can print. The lower the feed rate, the slower it prints. So I started doing some research for some Hotends, and I found one which, if the specs are right, should mean that the printer will run significantly faster. I will get better print quality, and it should just be a drop-in replacement to the standard V6 Hotend. and that is a TZV6, and I bought that from Amazon. And it comes with hardened nozzle, and it's an all-metal hot end, so it's a fully constrained metal path for the filament. So this hot end comes with a 0.4mm hardened nozzle, and I'm running 0.6mm so that I can have thicker walls on my prints, and also I can print in thicker layer heights so that prints complete faster. So on a live stream, I decided I was going to document the process of just simply swapping out this hot end and showing the test results. However, that was a little bit more complicated than I'd first imagined, even though this is a V6 drop-in replacement. So it appeared that the CR10 V2 doesn't have an exact replica of the E3D V6. So the replacement that I bought has very little clearance at the bottom of the print head. And I had some concerns around the fact that it would crash into the bed, crash into a print, and more importantly, it could crash my BL Touch sensor, bed sensor, damaging it, which means then I don't have mesh leveling and all of that cool stuff. I pressed on because I wanted to test, make sure that the hot end worked with all of the electronics of the printer. So I cut into the wiring loom. I added the attachment wires, the little plugs that come in the kit, and then connected the printer to the control box and tested to make sure that the temperature sensor was working, that the heater cartridge was coming up to temperature. So a word of warning, if you're going to attempt a replacement like this, you will be cutting into your printer's wiring loom. If you have any concerns about that, don't do it. This is not intended to be a tutorial, more process of me documenting what I'm doing. Oh, and another word of warning, if you're taking your 3D printer's head completely apart and you have a touch sensor or a bed leveling sensor, you will need to recalibrate your Z offset because you've disturbed everything inside, and therefore everything's going to be different. Even if it's off by like 0.2mm, which is effectively a layer height, that could be the difference between your print not sticking to the bed, or it could be that your print head crashes into the bed by 0.2mm. So, you know, or whatever your offset difference is, now you've reassembled your print head. So whenever you disturb your print head, you're going to need to recalibrate your Z offset. Oh, and did I mention that the heater cartridge is a 24-volt heater cartridge? That's quite important because if your printer is a 12-volt system, then this heater cartridge is going to struggle getting to its optimum temperature, and it's potentially going to throw thermal runaway alarms on the printer because it's trying to dump heat into this heater cartridge, but is not able to either maintain the temperature or it's not able to reach its temperature. And therefore, the printer safety system should kick in and say, you know, prevent what it thinks could be something that could trigger a fire. So at worst, it's going to trigger alarms. At best, you're going to see that this heater cartridge is going to very slowly come up to temperature. So that's just a word of warning. So now I know that this is all working with the electronics of the printer. I need to figure out what I'm going to do about attaching this new hot end to the printer. And on inspection, I can see there's very, very little clearance. Now, that could be because the nozzles I've had in the past are not the stock nozzles that came with the printer itself. I might have had a higher thickness nozzle, higher flow rate nozzle, and I might be being oversensitive, but I want to make sure that these machines run reliably and don't cause me loads and loads of headaches in the future. So I erred on the side of caution and decided I was going to redesign the housing for the hot end and drop the hot end down by 3mm. That should give sufficient clearance on the bottom of the print head, but equally will give clearance on the BL Touch. I can't drop it down too much, otherwise the BL Touch Pro won't actually reach the bed in its deployed position. And I don't want it to be in a position where it can actually crash into a print or the bed in its stowed position. So that's all of the sort of considerations that I've got. And it's going to be a little bit of trial and error. So I spun up Alibre Atom 3D and I created an assembly. And from here, I created the parts for the print head. To help me with the design, I scanned in the original parts using an all-in-one paper printer using the flatbed. And I've actually got a video on this technique, which you can find here. So I put the part into the scanner and use a measuring tape. I put that in there also. And that will be used later to calibrate the size of the image so that we can trace around certain parts and geometry of the head and bring that into the CAD program and have confidence that we're in the right place. So after modeling the back, I then model the front and I print out a test piece using the unmodified printer that I got. Remember, I've got two CR10 V2s. So once that prototype was completed, I installed some heat set brass inserts so that we can use the original hardware to attach to the printer. Now, before we get to actually test the printer, I decided that while I was in here, I was going to do a little bit of maintenance. So tightening up any loose nuts and bolts, make sure the belt tensions were correct, and then set the bed level. Once the bed level was set, I then had to recalibrate my Z offset. It's a painstaking process of running the mesh leveling wizard and then bringing the head to the center and bringing it down to what it thinks is 0. And then adjusting the height accordingly until you get the right amount of grab on a piece of paper at the center. Then run the bed leveling routine again and repeat the process of that feeler gauge, piece of paper feeler gauge test. It's always, when you switch to a new filament, it's always best that you actually calibrate it so that you run it at the right temperatures, because what's on the side of the reel is only an advisory and you need to hone it into your machine specifically. And also like things like retraction and to try and get the best print qualities. For me, this was doubly confusing because I've changed multiple things. So not only am I changing the filament type, I'm also changing the hot end, which now has a different profile, which is unknown to me. I'm learning this from the ground up. So there were a bunch of prints that I did that completely failed until such time as I figured out what the correct settings were. Once I did that, I was then able to print out the back and front in glass fiber and insert the brass inserts into that, and then take out the prototype head, replacing it with the new glass fiber one. And yes, I've disturbed the head again, so I've got to go through the bed leveling wizard to get my Z offset again. So once that was complete, I ran another print to get the housing ready for the second printer. Now, because I've been in and out of the guts of this machine repeatedly, I'm pretty well versed in how these machines are put together. So upgrading the second machine was a lot easier than the first because I'm now applying what I learned in the first example. Now, both machines are running reasonably well. I say reasonably because there's only been a limited number of prints that have come out of these machines, and I want to test it a little bit more before I commit fully. In the future, I will be upgrading my CR10 V1 to this style of print head, but what I will need to consider is I cannot use this hot end because it's a 24 volt system and the CR10 V1 is a 12 volt system. So thankfully, I do have a genuine E3D-V6 hot end on there. So I will be building the head around that particular hot end. And also the mount points on the V1 are different. So I'm going to need to completely re-engineer the back of the print housing so it fits the CR10 V1. But that's a future project. I may or may not do a video on that, but definitely I'll take some photographs and put that on community posts. So if you've got any questions about this upgrade, feel free to put a comment below and I'll get back to you as quickly as I can. Feel free to subscribe if you want to follow this journey as I bring these tools online and work through my workspaces with the ultimate goal of setting up my cottage industry, my cottage business. I think that's what they call it, right? So until next time, have fun, be safe. I'll see you in the next one.